Unit 7, Print Format. After completing Unit 7, you will be able to interpret a variety of print formats that use various units of measurement for dimensions. Locate and explain the purpose of information found in the title block. Determine tolerance variances of a part, feature, and weld from the print dimension and specified tolerance. Recognize and explain other formats appearing on prints, including sheet size, zoning, and security classifications. In order to be useful, a drawing or print must include a picture or map of the product and all the information needed to make or assemble the product. When first reading a print, the views, lines, dimensions, notes, and the amount of detail can be overwhelming. The best way to read a print is to mentally break it into smaller parts. This unit will help you understand the information found on a print. Remember, try to look at the shape of the part with the dimensions and notes removed. Second, try to determine the overall size of the part so you have some understanding of how big or small it is. Third, look at the title block for information about the scale, tolerance requirements, material, and part name. Finally, read all the notes on the drawing. By using this method to read a print, no important detail will be overlooked. You will also have a better understanding about where to find specific information you may need to lay out and fabricate the part. Shape description. Visible lines are used to show the visible features of a part. Views are used to show the length, width, and thickness of the part. Features that are not visible on the surface of the view are shown as hidden lines. The views and features combine to describe the shape of an object. Only the views required to adequately describe the shape of the object are found on the print. Size description. A properly dimensioned drawing includes all dimensions needed to give a complete size description of the product. The United States is in the process of converting from English measurement, inches, pound, quart, etc., to metric measurement, meter, millimeter, kilogram. Total conversion to the metric system is expected to take many years. But many companies, especially those selling products to the rest of the world, have converted to the metric system. Therefore, during this conversion period, you must be familiar with several print formats. A welder may have to work from prints that have dimensions in fractions, decimal fractions, metrics, dual dimensions. A dual dimension print has both English and metric values. Metric dimensions are usually in millimeters. The various dual dimensioning techniques and how the dimensions are placed on a drawing. Drawings are usually dimensioned in inches and common fractions when the object does not require a high degree of accuracy. Greater precision is indicated with dimensions are inches and decimal fractions. Print title block. Additional information about the product shown on the print can be found in the title block. Figure 7.7 summarizes most information in a title block. Specification on the print gives the exact grade or substance to be used in the weldment. For steel, it's AISI 1020, 60, 61, T6 for aluminum, etc. It is usually included in a section on the title block. Notes can also serve as material specifications not given on the title block. If they are used, notes appear elsewhere on the print. Remember, under no condition should the welder substitute a different grade or type of material for the material specified on the print. Tolerances. It would be costly and nearly impossible to make everything to exact specified sizes to keep costs within practical limits and if tolerance are permitted. A tolerance is the entire amount of variance allowed in the size of the part or object. It indicates how much larger or smaller a part of a product can be made and still be within specification. Acceptable tolerances may be shown in the title block or on the drawing in several different ways. In general, when a dimension is given in inches and fractions of an inch, unless otherwise indicated on the drawing, permissible tolerance can often be assumed to be plus or minus a 64th. The symbol plus or minus means the part can be made plus larger or minus smaller on that dimension by 1/64 and still be acceptable. When the tolerance is plus and minus and the variance is in both directions, it is called a bilateral tolerance. For example, if it were permissible to make the dimension larger and smaller, the dimension would read 2.5 inches plus or minus a 64th. So the part could be as large as 33/64 or as small as 2 31/64. However, if only one plus tolerance is permitted, the dimension can read 2.5 plus 1/64. Or if a minus tolerance is permitted, the dimension would read 2.5 minus a 64th. When the tolerance permitted is in one direction only, either plus or minus, is called a unilateral tolerance. Dimensions shown as inches and decimals usually indicate that the work must be done more accurately. Two methods of showing these tolerances are generally used on modern prints. A plus tolerance would be shown as 2.5 plus a 100th, or 2.51 over 2.5. A minus tolerance would be shown as 2.5 minus 100th, or 2.5 over 2.49. The dimensions indicate that the part can be used as long as that dimension measures within the indicated limits. Quantity of units. The print should also show the number of units needed to each assembly. A work order, including with each job received by the shop, indicates the total number of units to be manufactured. This aids in ordering sufficient material and helps determine the most economical method for manufacturing the part. A routing sheet or shop traveler may accompany the work order. The routing sheet or shop traveler is used to list the specific processes required to make the part a subassembly or assembly. The list is in order of operation and may include estimated or standard production times, machine or process numbers, and inspection requirements. Scale of drawing. When views on the drawing are made other than actual size, they are called scale drawings. Scale drawings are necessary when the part drawn is too large or too small and it would be impractical to draw the necessary views full size. Views on a print might be 1/2 size, twice the actual size, or actual size. A print with views drawn 1/2 the size is shown by the numbers 1/2 in the title block. The numbers 2/1 indicate the views of the drawing are twice the actual size of the part. Drawings made actual size are indicated by the numbers 1/1 or the words full size. Caution: never measure a scale the views on a print to get a needed dimension. Many prints are reproduced by enlarging or reducing the original, therefore the print scale changes. Finish. General finish requirements such as sandblasting, painting, plating may be specified in a section on the title block on some drawings. However, full finish specifications are usually listed elsewhere on the drawing. Along with the standards, the finish must be met. Revisions. The revision block indicates what changes have been made to the original drawing. The quality assurance systems used by your company may require the revisions number on the print be matched to the work order and routing sheet. Always check to make sure the print is in the latest revision. Next assembly. Next assembly information is necessary to provide the next step in the manufacturing and assembly operations. The term application is sometimes used in place of next assembly. Drawing title. The drawing title tells the welder the correct name of the part. A section of the title block gives this information. Print number. For your convenience in filing and locating drawings, industry provides each master tracing with a print number or an identifying number. Each sheet in a series of drawings is also numbered to indicate the consecutive order and the total number of sheets in the series. The rounding sheet generally indicates the print number. To assure the correct print is sent with the rounding sheet, always check the print number and revision number on the rounding sheet before welding. Heat treatment. Heat treatment includes a number of processes involving the controlled heat and cooling of a metal or alloy to obtain desirable changes in its physical characteristics and mechanical properties. Heat treatment can improve the metal's toughness, hardness, and resistance to shock. Additionally, heat treatment can also be used to anneal metals to make them easier to work with. One heat treatment process that may be specified for metals that have been welded or machined is stress relief. The heat treatment requirements are shown in the section of the title block. A C-note direction is placed in the block if the heat treatment must conform to specific standards, but specifications are placed elsewhere on the print. If no heat treatment is required, the word none or a diagonal line is sometimes entered into the block. Notes. Information not included on the title block or dimension views, but pertinent to the manufacturer or assembly of the part, is included under notes. Print sheet size. The bulk of the drawings used by industry are put on a standard size drawing sheets. This makes them easier to file and identify. A title block often shows sheet size. A prefix letter added to the print identification number may also be used to indicate print size. A list of standard sheet size is shown on Figure 711. Zoning. Zoning is a technique used to aid in locating details on large-sized drawings. The zones are indicated outside the border as letters and numbers. Figure 712 illustrates how zoning is used in a print. Classification. Some drawings have a security classification of top secret, secret, confidential, or restricted. The type of classification is noted on the top of the sheet and below in the title block. If your work involves using classified drawings, you will be instructed how to safeguard the security of these prints. Dimensioning symbols. The American National Standards Institute, or ANSI, has recommended changes in specifying circles and holes. However, both old and new standards will be found on drawings and prints for many years to come until present standards appear on all drawings. Because of this, it is important for the welder to recognize both methods of dimensioning symbols when reading a print.